Yes, welcome back. In the previous topics, we were discussing about the maximum stress theory. Now we are going to discuss about the maximum principal strain theory. So this theory is also called as an Newton's theory. So he derived this experimental and he proved that about the maximum principal strain theory. So according to this maximum principal strain theory, the yielding will occur when the maximum principal strain just exceeds the strain at the tensile yield point. Either it might be in the tension or it might be in the compression. See what the maximum principal strain theory says is when the yielding will occur with the maximum principal strain. Strain is nothing but when it changes from initial position to the original position, or it changes from, or it might be in a deflection, or it might be in a deformation which causes change in length by original length. So according to this theory, yielding will occur when the maximum principal strain just exceeds the strain. Strain is nothing but maximum principal strain exceeds the initial strain. Initial strain, whichever the initial strain is there, whenever it is exceeds the initial strain, that is the maximum principal strain, they at the yield, at the tensile yield point in the, either it might be in the compression or it might be a tension, at that particular point where the maximum principal strain will come into the picture, or the maximum principal strain will occur. If the Z1 and Z2 are the maximum and minimum principal values, that is corresponding to the sigma 1 and sigma 2. In this case, what we are going to do is sigma 1 will be equal to 1 by E into sigma 1 minus V into sigma 2, where E is nothing but a modulus of elasticity, and the sigma 1 and sigma 2 as a maximum and a minimum principal stresses. So when we want to see, now we'll see the diagram and we'll see. So this is an yield surface corresponding to the maximum principal strain theory. See what happens when this corresponding to the maximum principal strain theory. Strain is nothing but where generally the strain is nothing but a change in length by an original length, where you can able to see this is a sigma 1, that is a maximum, and sigma 2 is a minimum, where at this surface, when we going to consider this in a yield surface corresponding to the maximum principal stress, maximum principal strain theory, what happens, the sigma 1 will be equal to, you can say this sigma 1 will be equal to sigma naught, that into tau into sigma 2. Tau is nothing but a shear stress, however we are going to consider as a shear stress, and sigma 1 will be equal to, that is the maximum principal stress will be equal to sigma naught plus shear stress into the sigma 2. Now if you consider to the minimum principal stress, that is sigma naught into shear stress into the maximum. See, for the maximum we are going to consider with the minimum, for the minimum we are going to consider along with the shear stress, where you can able to see at the, these are positive xy, and this is the this axis what we are going to consider as a negative. So in this, what we are going to consider is the boundary of an yield surface, which is the boundary where we are going to consider this. Now what happens, sigma 1 will be equal to 1 by E. E is nothing but a modulus of rigidity into sigma 1, that is sigma 1 is nothing but a maximum principal strain, where we are discussing about this, along with the shear stress into the minimum principal strength. So sigma 1 will be greater than the sigma 2, that is the maximum principal stress will be greater than the maximum principal minimum principal strain. Now for the similarly, for the second condition, that is sigma 2 will be equal to 1 by E is nothing but modulus of rigidity into sigma 2, that is the minimum principal strain minus shear stress into the maximum stress. So here in this condition, what happens, the minimum principal strain is greater than the maximum, minimum greater than or equal to maximum principal strain. So this, for total, what happens, this result is nothing but modulus of rigidity into sigma 1 will be equal to uh, sigma 1 will be equal to maximum principal strain minus minimum principal strain into shear stress. So by equating this boundary layer, what we are going to get is, that is what we have seen in the yield surface corresponding to the maximum principal strain. So this is about the what this is about the maximum principal strain theory. Now we will discuss about the maximum shear stress theory. See, the maximum shear stress theory, or what we call it as a Tresca theory, is derived or is proved that equation. According to this theory, yielding would occur. Means yielding is nothing but an altimeter and maximum strength where it changes the position or the permanent deformation will occur. So yielding would occur when the maximum shear stress just exceeds the shear stress. So shear stress, normally shear stress is directly proportional to strain within the elastic limit. So what happened, that the shear stress is just exceeds the tensile point. Whenever the shear stress exceeds the tensile yield point, at that particular point the maximum shear stress theory will come into the picture. At the tensile point, whether the sigma 2, that is maximum, will be equal to the sigma 3 will be equal to 0. So this is what how we are going to consider that as an uh, maximum stress theory. So this gives us then a six conditions of the three dimensional. When you take as in a three dimensional, it will be having in a six dimensional, that is stress situations. One is sigma minus sigma 1 2, sigma 2 minus 3, sigma 3 minus 1. That is whether it might be x or y in the direction. So what happens when the three directional means one three positive and three negative will be there. Whenever we are going to consider the three planes, so you can able to see x, y, and then a z axis. So when you consider the three axis, always there will be a three axis means six dimensions will be there, are six conditions will be come into the picture along with the plus, that is three positive and three negative. See where you can able to see this, the six biaxial, the in a biaxial stress conditions, when sigma 3 will be equal to 0, sigma 1 minus sigma 2 will be equal to sigma into y. That is sigma 1 will be greater than the 0 and the sigma 2 will be, sorry, sigma 2 will be lesser than the 0. So here also again similarly sigma 1 minus, you can see the sigma 1 minus sigma 2 will be equal to minus sigma y. At that condition sigma 1 will be lesser than the 0 and sigma 2 will be greater than the 0. So same condition, it will changes repetitively. Next sigma 2 will be equal to sigma into y, that is sigma 2 will be greater than sigma 1 and sigma 1 will be greater than the 0. This is about the condition, third condition. Similarly, now sigma 1 is lesser than the sigma 2 and the sigma 2 is less than the 0 for the next condition. So again for the for fifth condition, sigma 1 will be equal to minus sigma y if sigma 1 is greater than the sigma 2 and sigma 2 is greater than the 0. Again for the last condition, that is sixth condition, sigma 2 will be equal to minus sigma y if sigma 2 is lesser than the sigma 1, that is will be lesser than the 0. So when it going to be proved is about this criterion agrees well with the experiment. You can able to see this circle where this indicates the yield stress in a pure stress, that is half of the yield stress, and that we call it as an, even we consider this as a pure stress, that we will consider that as a pure shear stress. So in this what we are going to indicate is whenever the maximum shear stress reaches to the it crosses or reaches the shear point, at that point yielding will occur. At that point the maximum shear stress will come into the picture. So this is how we are going to prove that, this is how we are going to prove that about the maximum stress theory, that is derived from the Tresca. So in this case the pure stress will be normally sigma 1 will be equal to minus sigma 2 and sigma 3 will be 0. So this gives us then a final equation will be sigma 1 minus sigma 2 will be equal to 2 into k, that we are going to consider as a sigma y. So this indicates the yield stress in a pure shear is half of the tensile yield stress, and this is also seen in the Mohr circle. So this we can able to derive even through the Mohr circle.